In this video, we're going to learn how to take the graph of a piecewise function and then write the actual piecewise function that matches that graph. So I'm going to colorize this so you can follow along more easily. We will do the first piece here in blue. Okay, so I'm just going to colorize it a little bit so you know this will be the blue function. So these are lines. So when we're dealing with linear equations, I'm thinking y equals mx plus b. So really, all we need is a slope and the y-intercept, and then we've got an equation for the line. So looking at this blue line, the line that goes through this, as far as the slope, I can see as I go from point to point, it's going down 1 over 2. All right, so that slope, down 1 over 2, that's negative 1/2, down 1 over 2. So the slope is negative 1/2. All right, so that's going to be negative 1/2 x. And then the y-intercept, the b, well, this ray does not touch the y-axis. But you can imagine if you extended this, eventually it would touch the y-axis. So that's what we're looking for. Where would this hit the y-axis if I extended the line? And I mentioned down 1, right 2. If I kept going, down 1, right 2, down 1, right 2, down 1, right 2, you can see that it would hit the y-axis right here. So this is the y-intercept at negative 3. So minus 3. So this is the equation of the line that goes through this piece. So that's what I need right here. So I'm going to have negative 1/2 x minus 3 for my first piece. Now, the line y equals negative 1/2 x minus 3 goes forever in both directions. But in this piecewise function, it has an endpoint and goes in one direction. So here's my endpoint. I need to know what x value this is so I can limit the domain. I'm going to write a domain restriction. Notice how this is an x value of negative 2, all right, because it's here to the left. At the x-axis, this is the point negative 2. So my domain restriction is going to involve the number negative 2. So is it going to be less than negative 2 or greater than negative 2? Well, see how this portion of the graph is going to the left? So that means it's going to be x values less than negative 2. Notice I didn't put or equal to. That was on purpose because this is an open circle. So I knew that I should not include negative 2 in this particular piece. All right, so that's it for the blue piece. Now let's do what I will call the red piece. All right, so this is the red. That's about to happen now. So I need an equation for this line. Again, I need the slope and the y-intercept. Now this seems to be going up 1 over 1. Okay, so 1 over 1, that's just x. So far I have x, because 1 over 1, you don't put anything. Next I need the y-intercept. I need the b value. Well, the y-intercept is right here. Okay, this is where this piece touches the y-axis at 3. So I'm going to put plus 3. So y equals x plus 3. That's the equation of this line. But this line does not go forever. It starts at an x value of negative 2. So again, I'm going to have my domain restriction if x and something about negative 2. But this time, this piece of the graph goes to the right of negative 2, goes to the right. So these x values are greater than or equal to negative 2. This time I put or equal to because right here at the end point it is a closed circle. So that means I should include the endpoint. So greater than or equal to -2. And that's it. That's how you convert a graph of a piecewise function into an actual piecewise function equation. Let's do that again for problem number 6. I might need this space, so I'm just going to erase. That rhymed. I'm so awesome. Okay, I'm going to do this little horizontal part first. It's actually the easiest part because horizontal lines are just equations. They're short little equations like y equals something. All right, a horizontal line is always y equals a number. So what number? Let's see. This would be -1, -2, -3, -4. So y equals -4 is the equation of the line that goes through here. So I'm just going to have a -4, all right, no x or anything like that. And then it's just time for the domain restriction, if x is. Now the endpoint here is at 1, okay, +1. So something about +1. Now, do I want x values that are less than -1 or x values that are I'm sorry, not -1. Do I want values that are less than 1 or greater than 1? Well, this is going to the left, so that's going to be values that are less than 1. Notice I did not say or equal to. This is an open circle, so the end point is not to be included. So that's it for this blue piece down here. Now let's do the red piece. Okay, now this is not a horizontal line. So I am going to need my y equals mx plus b form again, slope-intercept form. So remember, I'm thinking, all right, I need the slope to put here, and I need the y-intercept to put there. So let's start with the slope. This goes up 1 over 1, so that means the slope is 1. All right, so I would really just put x. 1x is just x. Now I need the y-intercept that goes here. This ray doesn't touch the y-axis, but if I extended this line by going down 1, left 1, like this, I immediately see that it would hit the y-axis right here at 1. So this is like 1x plus 1. So I will just put x plus 1 for the y-intercept. Right, so now I'm going to say if. Okay, let me just erase and clear this up again. So again, my endpoint is at 1. So I'm going to have if x is, and I'm going to say something about the number 1 for my endpoint. So will it be less than 1 or greater than 1? Because this is going to the right, I'm going to go ahead and say I want x values that are greater than or equal to 1. I said or equal to because I noticed this is a closed circle, which tells me that the endpoint should be included here. So greater than or equal to the number 1. Okay, that is how you graph those. And hey, I'm noticing that I was supposed to evaluate as well. So this time, I'm not going to use the equations because I was given the graph. I was not given the equations. So if I made a mistake, then my equations will be wrong. And if I use them to evaluate, then I will get wrong answers. I know that the graph is right. So if I can use the graph to evaluate, then I know my answers will be correct. So let's do that. So here's how you can use the graph to evaluate. These are x values. Okay, so I'm going to go over to an x value of 1, and then I'm going to look around and see where the function is. So here's an x value of 1, and then I see the function is here. at a y value of 4. So the answer is 4. Okay, let's do that again. I have an x value of -4. So 1, 2, 3, 4. So here's an x value of -4. So at -4, the function is here at -1. That's basically the y value. Let's do that again. I'm going to go to an x value of -2. Wait, I meant to draw a tiny little x right there. All right, I'm going to go to the x value, and then I'm going to see what's the y value that goes with it. So here's an x value. Now I need the y value. Whoa! The function is above and below this. Should I put 1, or should I put -2, or should I put both? I should put 1, because that is a closed circle. That actually is included. This open circle does not count. Open circle means that this point is not to be included in the function. All right, so 2 is the only answer here. All right, that is it for number 5. Okay, now evaluating number 6. Again, just using only the graph. I'm evaluating using the graph. So 0, so that's an x value. So here I am at an x value of 0. And I see the function at 0 is down below at -4. All right, let's go again. 3, that's an x value. All right, at 3, the function is up here at 4. All right, let's do that again. What about 1? The v of 1. So here we are at 1. I am going to look at that point up there, because that is a closed circle. Open circle doesn't count. So that's going to be 2, the y value of 2. All right, so that's how you can evaluate just based on the graph. Okay. All right, let's see. So here's another graph, and we're supposed to write a piecewise function for it. So here we go. Now this happens to be an absolute value function, and we'll write that, that value later when we do number 8. But so here's the vertex. So the vertex helps to separate this graph into 2 pieces. This piece on the left, which is going to be in red, and this piece on the right, which is going to stay blue. Okay, let's do the piece on the left first. So I need an equation for this line. So again, that's y equals mx plus b is what I'm thinking. All right, so I need the slope and I need the y-intercept. Let's start with the slope. I notice that the next point that hits on the grid is here. So rise over run. From point to point, I'm going down 2 over 1. All right, down 2 over 1. So that's -2 over 1. So that's -2. So my slope is -2. So I'm going to have -2x, which, by the way, means that I might as well look at the blue side as well. That's up 2 over 1. So that's going to be positive 2x. Okay. All right, now getting back to the red side, we're doing y equals mx plus b. We're trying to find the equation for the line that goes through this. So this is the mx part. We need the plus b part. We need the y-intercept of the red side. Now, this red ray, you can't see where it touches the y-axis. If I were to extend this, it's going to eventually touch the y-axis, but it's going to be way off the graph somewhere. And that's going to be hard to find. I don't want to guess, I don't want to estimate. So let's use the y equals mx plus b equation. So here's how you would do that. So thinking of, I'll just do it right here. Thinking of y equals mx plus b, I propose using the vertex for x and y. Now the vertex here is the point, let's see, 5, 6. Okay, that's x and y for the vertex. So for the y value, I can use the 6. For the m, I already know that the slope is -2. We discussed that earlier. And for x, I can use the 5. So I have everything except for the b. So that means 6 is equal to -10 plus b. And then I would add 10 to both sides. And that gives me b is equal to 16. So that means the equation is -2x plus 16. And it makes sense. If we extended this line, it's not hard to imagine that it would hit at about 16. All right, it's always good to check and make sure that the answer you're getting makes sense. You know, if we got, for example, -8, which is way down here, it wouldn't make sense that this graph would somehow hit the y-axis at -8. But 16 seems about right. Let's do the same thing for the blue side. Let's practice our y equals mx plus b skills again to find the b value of the blue side. So y equals mx plus b. Again, let's use the vertex. It works for both. So again, we'll use 6 for y. But this time, the m, the slope, is +2 instead of -2. And we'll still use the 5 plus b. So that's 6 is equal to 10 plus b. Subtracting 10 from both sides gives you -4 is equal to b. So that means this is 2x minus 4. Now notice in this case, if we extended this line, because we were doing the blue line, right? Imagine that we extended this line until it hits the y-axis. We would wind up going down to left 1, 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 down to left 1. Oh, look. You see that it's hitting the y-axis right here at -4, which is the same thing we found using our y equals mx plus b equation. All right, so you can do it whichever way you want, but you saw that for the red side, you really didn't have the option of extending the line because it goes off the graph. So you really need to be able to do the y equals mx plus b. Okay, now, so that was a piecewise function for this, which clearly they're looking for here. Now, for number 8, we're supposed to find an absolute value function for this same thing. So when they ask us for an absolute value function, that means with this type of symbol, all right, the absolute value symbol. So again, that vertex, remember, was 5, 6. This, whereas the parent function started at the origin, this has shifted right 5 and up 6. So inside is where the left-right motion happens. So if I want to go right 5, I need x minus 5 in here. It's the opposite of what it looks like. If I want to go up 6, I need a plus 6 on the end. This one works like normal. Positive is up. And in the very front, I need a number that reflects the slope of the right-hand side of this thing. So notice this goes, it was up 2 over 1. The slope of the blue side was 2. So we'll have a 2 right here. And in general, if it's an upward-facing V, this number will be positive. If the V was facing downward like this, then this would be a negative. All right, but that's it. That's the absolute value function for this graph. The axis of symmetry is the vertical line that goes right down the middle. This green right here would be my axis of symmetry. Okay, and that's a vertical line at 5, so that would be x equals 5. Vertical lines have the equation x equals a number. Now, the domain and range. Well, the domain is going to be negative infinity to positive infinity. The domain is always how far the graph goes left and how far it goes right. So it goes left forever, right forever. So that's negative infinity to positive infinity. Now the range. The range reflects the y values covered by the graph. So how far it goes from bottom to top. The lowest value on the graph is at 6. All right, this is the bottom. And then from there it goes up forever. So bottom to top is 6 to infinity. And we will put that 6 in a bracket because the graph does touch 6. It hits 6. 6 is included in the range. And it goes up forever. Okay. Now, last but not least, let us evaluate W at 4. Since the graph is the thing that they gave us, I want to use the graph, if possible, to evaluate. So W of 4. So remember, this is an x value. So let's go to 4 on the x-axis. All right, so here's 4. Now I'm looking up in the air, and I see that at this x value, the function is here, at this y value. So 8. So at an x value of 4, the y value is 8. At an x value of 5, well, that's right at the axis of symmetry, yeah? Maybe I'll change colors. So at an x value of 5, all right, meaning right here on the axis of symmetry, the y value is 6 because it's the vertex. All right, and at an x value of 7, I'll do the highlighter yellow. At an x value of 7, 7 is right here. The y value is, it's probably 10. It seems to be 10. It's a little bit hard to see because it's starting to go off the chart. So you know what would be fun? Let's use our equation, because if our equation is right, then we should get the right answer from the graph or the equation. So let's try using our equation this time. Okay, so the equation is 2 times absolute value of x minus 5 plus 6. So if W is 7, that makes 2 times the absolute value of 7 minus 5 plus 6. So 7 minus 5 is 2, so it's 2 times the absolute value of 2 plus 6. Now the absolute value of a number is the distance of that number from 0. So basically it's going to take that number and just make sure it's positive. If it's a positive number already, it'll just stay positive. So this is the same thing as 2 times 2, all right, because the absolute value of 2 is just 2. All right, the absolute value of negative 2 is also positive 2. So this is going to be 4 plus 6, which is 10, which is what I was guessing based on the graph. All right, but notice how the function works as well. So W of 7 is 10. And that is it for this video, my friends. I hope it has been helpful, and I will see you on the next video.